discussing is coplanarity of two lines and the equation of plane containing them. Now vector equation of line 1 is a1 plus lambda b1 vector, a2 plus mu b2 vector. Suppose these are two lines in the vector form. Now these two lines are coplanar if a1 vector dot b1 cross b2 is equals to a2 vector dot b1 cross b2. Now these two lines are coplanar if this condition is satisfied, and the equation of plane containing them, that will be r1 vector dot b1 cross b2. R vector dot b1 cross b2 is equals to a1 vector dot b1 cross b2 or a2 vector dot b1 cross b2. Clear? अगर two lines coplanar show करनी है and they are given in vector form, then this condition will be satisfied. Then the equations will be coplanar, and equation of plane containing these lines will be this. Now if the Cartesian form is given, Cartesian form of line x minus x1, y minus y1, z minus z1. Second equation is x minus x2, y minus y2, z minus z2 upon L2, M2 and N2. If Cartesian form is given, then these two lines will be coplanar if x2 minus x1, y2 minus y1, z2 minus z1, L1, M1, N1, L2, M2, N2, that is equal to 0. And equation of plane containing these lines will be, equation of plane containing these lines will be x minus x1, y minus y1, z minus z1, L1, M1, N1, L2, M2, N2. Or instead of x1, y1, z1, we can write x2, y2, z2. X minus x2, y minus y2, z minus z2, L1, M1, N1, L2, M2, N2, that is equals to 0. Now if vector form is given, then we will apply these formulas, and if the Cartesian form is given, then we will apply these formulas. So let us start with the question now. Question number 1. Show that the lines r vector is equals to I plus j minus k plus lambda 3i minus j, and the line r vector is equals to 4i minus k plus mu 2i plus 3k are coplanar. Also find the plane containing these two lines. First we want to prove that these are coplanar. Then what we have to show, a1 vector dot b1 cross b2 is equals to a2 vector dot b1 cross b2. Now what is a1 here? This is a1, b1, a2, and this is b2. First find b1 cross b2. b1 vector cross b2 vector, I, j, k. b1 is 1, 3, minus 1 and 0. b2 is 2, 0 and 3. So b1 cross b2 will be minus 3, minus 0, 0 minus 9, k is 0 minus minus plus 2. So b1 cross b2 has value minus 3i minus 9j plus 2k. Now find the value of a1 vector dot b1 cross b2. a1 vector is I plus j minus 9 minus 1 into 2. So we get minus 14. Now A2 vector dot B1 cross B2. A2 vector has value 4i minus k minus 3i minus 9j plus 2k. 4 into 3, j is 0, minus 1 minus 2. So minus 14. A1 vector dot B1 cross B2 is equals to A2 vector dot B1 cross B2. Therefore, given lines are coplanar. Therefore, given lines are coplanar. Now, equation of plane containing these lines. Equation of plane containing these lines, that will be equal to R vector dot B1 cross B2, A1 dot B1 cross B2. So we get R vector dot minus 3i minus 9j plus 2k. A1 dot B1 cross B2 has value minus 14. Take negative common from here. 3i plus 9j minus 2k equals to 14. This is the required equation of plane containing these two lines. Now the next one is prove that the lines x plus 1 by 3, y plus 3 by 5, z plus 5 by 7 and the line x minus 2 by 1, y minus 4 by 4, z minus 6 by 7 are coplanar. Also find the plane containing these two lines. Now these two lines will be coplanar if we will prove that x2 minus x1, y2 minus y1, z2 minus z1, l1 m1 n1, l2 m2 n2 equals to 0. General equation of the line is x minus x1, y minus y1, z minus z1, L1, M1 and N1, x minus x1, y minus y1, z minus z1, L2, M2 and N2. Put the values. x2 minus x1, 2 minus minus plus 1, 3. y2 4 minus minus plus 3 7, 6 minus minus plus 5 11, L1 M1 N1, L2 M2 and N2. Now solve these values. What we get? 3 into 7 into 5 minus 7 into 4, 7 into 1 minus 7 into 3 plus 11 into 12 minus 5. 17, 7 into 7 into 3, 21 minus 98 plus 77. ये क्या आया हमारे पास 77 plus 21, 98 minus 98 0. Therefore given lines are coplanar. Note up to here. Now we want to find equation of plane containing these lines. That will be equal to x minus x1, y minus y1, z minus z1, L1 M1 N1, L2 M2 N2 equals to 0. X minus x1, x1 is minus 1. So x plus 1 y plus 3, z plus 5, 3, 5, 7, 1, 4, 7. Now solve this to find the equation of plane. X plus 1 into 35 minus 28, y plus 3 into 7 minus 21, z plus 5 into 12 minus 5 equal to 0. So we get x plus 1 into 7 into z plus 5. So 7x plus 7 minus 14y, 14 into 3 plus 7z plus 7 into 5. 7x minus 14y plus 7z, 35 plus 7, 42 and 42 will get cancelled. By taking 7 common, x minus 2y plus z is equals to 0 is the required equation for the plane containing these two lines. Now the next one, show that the lines x minus a plus d upon alpha minus delta is equals to y minus a upon alpha, z minus a minus d upon alpha plus delta, and the line x minus b plus c upon beta minus gamma, y minus b upon beta, z minus b minus c upon beta plus gamma are coplanar. We want to prove that these two lines are coplanar. Then we have to prove this. First we have to find value of x1, y1, z1, x2, y2, z2. We can write this as minus a minus d, y minus a upon alpha, z minus a plus d, and this is x minus b minus c, y minus b upon beta, z minus b plus c upon beta plus gamma. Now put the values. X2, x minus x2 is b minus c minus x1 a minus d, y2 minus y1, z2 minus z1, L1, M1, N1, L2, M2 and N2. Now this will be equal to B minus C minus A minus minus plus D, B minus A, B plus C minus A minus D, alpha minus delta, alpha, alpha plus delta, beta minus gamma, beta, beta plus gamma. Now apply the operation on it. Operate C1 as C1 plus C2. What we get? C1 plus C2. B plus B minus A plus A. So 2 times C1 plus C3 if we will apply, then it will get cancelled. B plus C and minus C will get cancelled. Plus D and minus D will get cancelled. 2 times B minus A. Alpha plus alpha, 2 beta. This is B minus A, alpha, beta, B plus C minus A minus D, alpha plus delta, beta plus gamma. If we take 2 common from column 1, then we have left with now 2 columns are identical. Column 1 and 2 C1 and C2 are identical. Therefore, this determinant will be equal to 0. Therefore, the given lines are coplanar. C1 and C2 are identical. Now next one, find the vector equation of plane that contains the lines r vector as I plus j plus lambda I plus 2j minus k and r vector as I plus j plus mu minus I plus j minus 2k. Also find the length of perpendicular drawn from the point 2, 1, 4 to the plane thus obtained. Now the given two lines passes through a vector I plus j and parallel to b1 I plus 2j minus k, b2 as minus I plus j minus 2k. Clear? The two given lines pass through a vector is equals to I plus j and are parallel to vector b1 and b2. Therefore, equation of plane containing them will pass through a vector, and since the plane contains the lines, क्योंकि जो plane है contains the lines, therefore the normal of the plane will be b1 cross b2, because plane is parallel to these two lines are parallel to these vectors. Therefore, plane will be parallel to b1 cross b2. To find n vector, b1 and b2, 1, 2, minus 1, minus 1, 1, minus 2, minus 4, plus 1, 1, plus 2, 1, plus 2. So, minus 3i plus 3j plus 3k. Now, vector equation of the required plane. हमारे पास फॉर्मूला था वेक्टर इक्वेशन के लिए r वेक्टर माइनस a डॉट n इक्वल्स टू 0. So we can write it as r dot n is equals to a dot n. R vector dot minus 3i plus 3j plus 3k. A vector is I plus j dot minus 3i plus 3j plus 3k. Taking the dot product, minus 3 plus 3 plus 0. So we get the required equation of plane as minus 3i plus 3j plus 3k equal to 0. This is the required equation for the plane. If we take 3 common, then we can write it as minus I plus j plus k equals to 0. Now we want to find the distance between this plane and the point 2, 1, 4. Distance between the point 2, 1, 4, we can write it as 2, 1 and 4. This dot product with a dot n is minus I plus j plus k. D here is 0. A dot n minus d upon magnitude 1 square and 1 square. 2 into minus 1, 1 into 1, 4 into 1 upon square root of 3. So 3 upon square root of 3, that is square root of 3. Now next one, find the equation of plane passes through point 0, 7, minus 7 and containing the line x plus 1 upon minus 3, y minus 3 by 2, z plus 2 by 1. Now equation of plane passes through this point. Equation of plane passes through 0, 7 and minus 7. What is the equation of plane? A, x minus x1, B, y minus y1, C, z minus z1 equal to 0.